what we looked at is the pre-industrial climate, which means the Holocene, which is the mid-Holocene until 1750 and today, and especially the impact of both greenhouse gases but also air pollution on making this climate as stable as it was, because the past 6,000 to 10,000 years the climate was very stable, and that allowed humanity to develop its agriculture in a stable climate. We'll also look at what this means for the more recent climate and for the present climate, so how fast the climate is currently changing, and also what the implications will be for the near-term climate. And this research builds on the work led by James Hansen et al. In 2023, the paper Global Warming in the Pipeline, for which I was a co-author. And we look at the impacts of clean air regulations on regional climate change, especially regionally, where it can cause an increase in warming, heat waves, and precipitation. And with these conclusions, we call for precautionary adaptation and mitigation, which is crucial because of these rapid changes. How this presentation is structured is that I will start with showing a part of the presentation of Climate Chat, where I talk with Dan Miller about part of this research. I will include some new graphs and updated graphs therein, and I will include footage from Madagascar of how they are still using traditional biomass burning and burning the grasslands as they've been doing for thousands of years. And I will include visuals on how people are still cooking using biomass, and that also contributes to emissions of both greenhouse gases and aerosols. And now let's start with the conversation I had with Dan Miller. Right, this is the total greenhouse gas forcing from 130,000 years ago to today, which of course this was the Eemian, as I mentioned. The Eemian, this was the warm period when sea levels were 5 to 10 meters higher than today, and this was the Holocene, and now we are here. That's just looking at all the greenhouse gases as was also part of Global Warming in the Pipeline paper. We showed this data. We're looking at different methods to estimate this, but looking at all these greenhouse gases together, just so methane, CO2, etc., and then use that to estimate the value of in watts per square meter of forcing, which maybe I think I've explained that before, what a forcing is, but that's the amount of heat that's forced into the system by these greenhouse gases into the Earth system for every square meter of Earth's surface. And the Earth has a surface of 510 million square kilometers, which is 510 trillion square meters. That's a lot of square meters. But there's some questions about why the Holocene, which is this period, the greenhouse gases increased, but there was no warming, or there was even cooling. And also, if this was almost as high as this, haven't sea levels risen much more? So these are questions where there are still some missing answers for. And in Global Warming in the Pipeline paper led by James Hansen, one important hypothesis that was put there was that part of this was mitigated, this increase, because the greenhouse gases started increasing, also because of the agricultural revolution. People started burning forests, people started growing rice, which emit methane, land clearing. So a lot of changes and a lot of emissions of greenhouse gas over thousands of years. And what we put forward in this paper was that this could be mitigated in part by an increase also in air pollution. And it might be hard for people to imagine that the pre-industrial
civilizations were able to already control in a way the global climate by increasing greenhouse gases, but mitigating the warming by increasing also aerosol emissions, which reflect sunlight and make clouds brighter. But I live and work often also in developing countries. I work in Ethiopia, for example. I've been to Madagascar, and I've been around the world. And what you see there is people burning a lot of wood for cooking, but also burning a lot of grasslands.
So this is Madagascar. So in Madagascar, people are still burning their mountains down for the cattle. You can see it here. So there's very few trees because the mountains are burning. So they burn down the grasslands, they burn down the trees, and then the cattle can come and eat the young grass,
which starts growing again after the rainy season.
When you know that this should all be covered by trees without humans, it's quite a scene.
Pastoralist farmers have been turning biomass into CO2 and aerosols like this for thousands of years.
You have it's incomplete combustion because the fires don't burn very hot, which produces a lot of smoke. If you make a fire and your wood hasn't dried well, you know there will be more smoke than if the wood has dried well, because it takes also a lot of energy to evaporate the water, and then the fuels can combust very efficiently, and you have this incomplete combustion which produces all these aerosols, which also reflect sunlight or absorb this sunlight in the atmosphere rather than let it reach the surface. So what we propose there is that this also contributed to cooling, well, and compensated for the warming effect of these greenhouse gases, where we said starting about 6,000 years ago to 1750, there was a increasing aerosol forcing from half a watt of cooling between 6,000 years ago and today, or to 1750, sorry. And if you add that aerosol forcing, you see that this forcing is very stable. So that can help to explain why the temperature of the Holocene, so the past 6,000 years, 10,000 years, was so stable, because we helped to stabilize the climate by emitting greenhouse gases and emitting aerosols, and that stabilized the climate. And then also, if you look at the EMIAN is then much higher because you shift the baseline. Yeah, that's also about the baseline, because you shift the baseline up by half a watt, because 1750 was cooled by half a watt. Then it shows that the EMIAN was much, the climate forcing of the EMIAN was much higher than if you don't take that into account. And then if you look at these two together, you see, okay, of course I also added the greenhouse gas aerosol forcing here on top of 1 watt per square meter. So that's still because we increase aerosols after 1750, causing more cooling. So that also that makes the last glacial period less negative than if you wouldn't take that into account compared to 1750. You see, because this is more negative. This is about 3 watts, and this is about 2.5 watts. It's a bit counterintuitive, maybe, but this is what the data shows. And then but this during the last glacial maximum, global sea levels were over 100 meters lower than they are today, because there was so much more ice, because it was much colder globally. There was much more ice on North America and Europe, and that caused the world to cool down. and that produce ice and the 2 degree sea level.
That's over for Americans. That's over 300 feet. So back in the last ice age, sea levels were over 300 feet lower than they are today. Florida was, I think, 3 times wider than it is today. You could walk from Russia to what's now Alaska. I mean, that's
yeah, and you could walk through. England was part of the continent.
that's
UK,
right. England, you could
United
walk
Kingdom
to
was part
Europe.
of the
That's right.
continent. Yeah,
Yeah. And it wasn't that long ago. I mean, like
yeah,
15,
yeah,
18,000 years ago, right? So.
yeah. So then, indeed, and it started melting quite gradually. Also, because if you look at this line, yeah, it might seem quite steep, but this is 10,000s of years. So this might seem steep, but it's really not as steep as this line is.
That line is. And that's why people don't really understand that when we talk about sea level rise of 10 feet this century, which sounds a crazy large amount, it's really just a tiny fraction of the drop in sea level in the last ice age. So we're really playing with fire, I guess, is an apt analogy. But
Yeah.
keep going.
Yeah, so these are modeling studies showing that if you look at they use the greenhouse gas concentrations, and if you look at the models, there should be warming over the past 12,000 years. So there should be warming also over the past 6,000 years. If you look at if you put all the greenhouse gas concentrations, which are taken from ice cores, from these small bubbles in ice core, you can if you put that data into a climate model, you would estimate that there would be global warming over the past 6,000 years. But if you look at the reconstruction of the data, this 12 to 6,000 years ago, there was warming, but from 6 to 0, 6,000 years ago to 1750, there was cooling, especially in the northern hemisphere, and that's in part because of the solar cycles, the Milankovitch cycles, but also even the climate models show that there should be warming. So then why is that? And we estimate that in part is because of these aerosols.
Right. And so that's when agriculture was going on and people were burning. People don't realize, but I think it's a third of all non-ice covered land on the earth is used for meat production, cattle grazing, growing food for cattle and things. And that started long, long ago, and people burning down forests to clear land, and each little one doesn't have a big impact. You add it all up, it has a huge impact.
Yeah, and it's also because of like now we burn biomass very efficiently relative to how we did it before, and I think most people who listen to this, and most scientists also studying this, I think, don't spend a lot of time sitting in huts in Africa burning biomass, or raising cattle on the highlands of Mongolia or something, right? So that there's really if you spend time with those people and you see what they do to survive, they just like light the mountains on fire and wait for the fire to disappear and the rain to start, and then they have these fresh grass which animals can eat and grow fat on, and then it makes sense if you understand, but it's often not in. I think it's not surprising that this has been overlooked, has likely been overlooked, and because and I think it's the same with shipping. So why we'll get to that, but has the effect of shipping emissions been largely overlooked? The sulfur emission from shipping, I think because most scientists don't spend a lot of time on the oceans, right? And or let alone study the regulations these super tankers have to adhere to. There's some exceptions,
but not just in the developed world. I spent a lot of time on farms in Mexico because of one of the companies I was working with, and they're taking certain kinds of crops, and just burning them, to clear them up, and to help the land for later use and things like that, and filling the skies with smoke. And it's just a normal, it's happening today. This is not like not too far. I guess there's air pollution regulations in the United States that might prevent that kind of thing, but most of the rest of the world, India, it's a very popular thing to do as well. So
yes, exactly. So these 2.5 billion people still using biomass for cooking in relatively inefficient cooking technology, with relatively inefficient cooking technologies as well. And then someone asked this question to me today, like, what impact does it have, and how does it compare to sulfur emissions, and that's really complex, right? Because sulfur in a way is very nice and simple to study, because it's just these very small, it's emitted as SO2, sulfur dioxide. It's a gas, and then it forms these bright white yellowish particles which reflect sunlight and act as condensation nuclei to create clouds and make clouds more white. It's that's very uncertain what the effect of that is on the climate. There's so many uncertainties on where it is emitted, how high it is emitted, what time of the year it is emitted, and what is the background load of aerosols from plants, from algae, etc. It's already very complex. But what is in the smoke from biomass burning, cow dung, different species of trees, different humidities of different wood moisture content, all these aspects is so much more complex even than that. And then like how many tons per day. So and whether it rains or not. So there's so many variables there to include. And what happens if it deposits on snow, and then it absorbs sunlight, causing the snow to melt, right? All these that's really even more complex. But yeah, that's of course but the health effects of these air pollution, especially in households where they are cooking with the biomass, that's really bad. That's about 4 million people, mainly women and children, die every year from using biomass.
This video shows the baking of the injera, which is a Ethiopian flatbread. This is done here at a bakery at the University of Bahrdar. And this is a clean cook stove. It might not look like that, but this is already a much cleaner way of baking these flatbreads than is done traditionally on open fires. And there's of course still a lot to be gained by having cleaner fuels, or even better, use electricity for cooking, because then most of the air pollution is mitigated, and that of course will have a lot of health benefits for the women and the children.
So that's I think I think that we should start there, and that's what I'm working on. But I think that's really where we should start to reduce air pollution first, and of course, so reduce greenhouse gas emissions, etc. But if you want to reduce health impacts of aerosols, start in the kitchens of mothers and with their kids.